In these next few examples, the problem is set up a little bit differently. This time it says find the value of z. In our previous problems, we were given values for z, and we were looking for probabilities or area under the curve. Now we're given a probability or the area under the curve, and we're being asked to find z. So it says, find the value of z such that 0.13 of the area lies to the left of z and round to 2 decimal places. So this right here is our probability, meaning we could change this decimal into a percent, and what this means is 13% of the area lies to the left of your z value, and we're needing to find out what our z value is. So you're needing to remember that we have this basic idea that the area under the curve of a normal distribution curve is considered as equal to 1, or we could say it's equal to 100%. Okay? So if they're telling us that 13% of this area is to the left of some z value, and we're always going to have our mu or our mean set to 0. So think about this area under the curve as being 100%, and how could we draw a line so that a small part of it, only 13%, is to the left of our z value. So this is what we're needing to think about, and don't worry about that yet. Okay, so 13% would be a small amount of this whole area, which is 100%, and I want that 13% to be on the left side of whatever my z is. So this is just setting up the idea and the diagram. Then you're going to use your probability tables that I sent in an email, and we're going to be looking up this probability. Now, just as a reminder, the way this table works, it has a z right here that's telling us that these are our z values. And inside the table, all these numbers are the probabilities or the areas under the curve. So this time we're given the probability. So we're needing to look in here until we can find 0.1300, or as close as we can get to that. Okay, so 0.1300. Okay, so this is a little bit below 0.13, and this is a little bit above 0.13. And you want to get as close as you can. 0.1292 is just a little bit less than 0.13. So this is the one we're going to use. So going out to the z-score, negative 1.1, and then going up and seeing that that's 0.03. That's how we're getting negative 1.13 as our probability if the area to the left of our z-score is 13%. Okay, so let's look at another example of this type of problem. It's very similar, except this time it says find the value for z such that 0.14 of the area lies to the right of z. So in other words, 14% of the area lies to the right of z. Again, your whole area under the curve is 100%. So if we want just the small amount of 14% to be to the right of our z-score, this is where the line would fall, somewhere similar to that. So again, we're needing to find this z-score, and how we're going to do that is in 2 steps. Since we can only find probabilities or area under the curve for a z-score going to the left, we're going to do 1 minus our 14%, and then that's going to give us this probability or this area under the curve. So 1 minus 0.14 gave me the 0.86. That's this area. And now I'm going to look up this area in my chart, and I'm going to find the z value that goes with it. I want to get as close as possible to 0.8600. So I'm going to be using this chart, 0.86, and you just have to hunt around for it. So here is 0.8599. This is a very small bit away from 0.86, and this is quite a bit over 0.86. So we're going to use this one, and we're going to go to 1.08. That's the z-score if the area to the right of our z-score is 14%. Then there's one more example that's similar to this. This is another one that's asking for area to the right of z. This time it says 6% of the area is to the right of z. So again, I'm just setting up my diagram. I'm looking for this z-score, so I need to know what this area is, and I'm finding that by doing 1 minus the area that I'm given. That's how I get 0.94 for this area here. Then I'm looking up 0.94 in my chart, in my table, and when you look it up for yourself, you're going to see that there's 2 numbers that are equally close to 0.94. This one is just a little bit under, and this is a little bit over. So this is the value that I'm going to use. And I looked it up, and I found my z-score, and this is the z-score for 0.94.